In the last demo of this lecture, I'm going to show you how to use certain built-in functions to the SD card library that allow you to browse through directory structures or file structures, extract information about the files, such as the file name and the size in bytes, and determine what kind of file a particular file is. Just as a parenthesis, in a file system, you get basically, in a file system, everything's a file, but you can get two different kinds of files. So one is a normal file, like a text file, which we saw in the second demo when we created that datalogger.txt file, but you can also have directories. So think of directories as normal files which contain other files. So to do the demonstration, I earlier created a directory structure in my SD card. So I created a bunch of directories that also include directories themselves, and stored a few text files in each one. In the demo, I'll show you next. In the sketch I'll show you now, we will go through these directories in what's called a recursive way and print out the files in each directory and their sizes. So let's start the sketch first, and then as always go through it and have a look at it line by line. Whoops, there was an issue here. Failing that, I will disconnect the Arduino and connect it again. Right. Done. So it's done, worked. Let's check out the monitor. So that's what the output is until it finishes. Done. So what we have is this little sketch going through the contents of the file system of the SD card, picking up files such as the data log that we created in the demo 2, printing out its size in bytes, then moving on to other files. If a file that it hits is actually a directory, then it will browse inside the directory and print out whatever it finds. So you can see that this is recursive. This is a Spotlight directory. Further down, you can see, so I created earlier folder 1, and that contains 2 text files, and here's folder 2, which contains its own text files plus another folder inside folder 2 with text files of its own, until it finishes and there's nothing else to show us. So how does this work? Let's have a look. So again, the sketch starts like in the second sketch. We include the SD card. We're going to create a root object, which is of kind file or of type file, and we initialize serial port and the card, just like we saw in demo number 2. Now what happens here is that in the setup function still, we try to open up the root of the SD card by saying open parenthesis slash. So slash represents the root of the file system, and we'll put this object, which is, remember, of type file. SD card does not discriminate at this point between a normal file and a directory, so we're going to put this object into this create a reference called root. Then we're going to call the print directory function. We're going to pass the root object, and we're going to say that this is the first level directory that we are inspecting. And as we are getting deeper and deeper into the file structure, we'll be increasing that number to become 1, 2, 3, etc., depending on the level in the file system that we are at. From here, our program, the Arduino, is going to jump to the print directory function and starts executing what's inside this part of the program. So it starts with sorry about that. Okay, so it starts with creating a loop which essentially never ends. So for as long as the condition is true, which is always true, then go through the loop which starts here and ends down here. Of course, being in an infinite loop is not a good idea, so the sketch contains a way out of it. We'll see that in a few seconds. So the first thing that happens in here is to try to open up a file that exists inside this directory. So we say go into whatever we are now in the current directory and try to open up the next file down. And then we're going to use this as a handle to this file. So entry, just like root, is of kind file. If entry doesn't exist, then this expression is going to return false. We test for this condition by using the bang symbol. So if this truly is false, then it means that this directory doesn't contain anything, right? So we break out of this infinite loop. So we then get out of print directory. Otherwise, if there is something in here to look at, then what happens next is that we first create a series of tab values. So we start embedding the beginning of the next line so that we can show that a file is contained within a directory. So next we continue by printing out the name of the file entry. We do that by calling the attribute name for the object entry, which is of type file. If this entry is actually of type directory, and we know that by asking is entry a directory, and this becomes true, then here's the recursiveness. We are going to call a new instance of the print directory function. We're going to pass now the new object that represents the current directory, not root as earlier, but whichever directory we are in now, which is represented by the entry object. And because now we are in a deeper level in the directory structure, the file system, we are going to increase the num tab by 1, so that the files that we printed out that belong to this new directory will be embedded by an additional tab character. So they'll be aligned further in the line. If, however, entry is a normal file, then add a couple of tabs and print out its size. So we just call entry.size, and that returns the size of the file in bytes. Just to make sure that we get a human readable number, we make sure that the size is represented in decimal notation instead of hexadecimal or binary or something else. Once we're done with going through the entry object, we'll close the handle to this file, in this case to this directory. Congratulations! You now know how to write text data to your SD card. But what about reading? I did not show you how to read text from the card because I'd like you to work this function out yourself. Have a look at the documentation page for the read function and a sample sketch that shows you how to read text from a text file.